Yeah, so today what we are going to do is this. Basically, we are going to talk about conceptual data modeling with the entity relationship diagram. So basically, today my focus will be giving you an idea of how to do and how to create entity relationship diagrams through the conceptual data modeling. So at the end of the course today, you will be able to infer entity relationship diagram, which will be kind of a baseline for the database design. So let's see. Oh yeah, let me put the chat box just in case you guys ask anything. Okay. Okay. Okay, so this is what we talked last time. So last time I basically gave you an introduction about the database system, and I talked about why we are using database approach. And by using database approach, there are several advantages you can gain. There are three things, like there are three problems we are able to reduce by utilizing database approach. And there are three other benefits we are able to improve by utilizing database approach. So those were this kind of thing. Basically data redundancy, inconsistency, and isolation. We want to reduce it. So if you don't use a database approach and if you simply store your data inside the Microsoft Excel file or textual data or textual format like that, then there will be a problem. So one of the problem is uh, data redundancy. So data redundancy is a problem uh, referring to the situation that there are multiple copies of data stored in multiple places. So for example, if you use database approach, then there will be centralized database system. So all of your data will be stored there. So there will be no redundant or duplicate information. However, if you don't use a database approach, if you simply store all your data in a texture file or Excel file, then what's happening is this. So when a certain employee, when he joins to a company, the human resource department will keep his information. And let's say that this guy is actually working in the IT department in a company. Then IT department company will also have a copy of that employee's information. That means that the same information is stored in two different places. So in this case, there is a data redundancy problem because we have a redundant information. We don't need to have two copies. We just need to have one copy stored in centralized system. However, if we don't use database approach, this problem may happen. And the second problem we talked about last time is data inconsistency. This is related to the first problem. So because there are multiple copies stored in multiple places, there might be inconsistency in the data. So let's say that this guy's name is Billy Jones, and when he joined the company, he used Billy. He spelled the name like this. And when the data is transferred to the IT department, when IT department is recording this guy's information, they made a mistake. So it's possible they typed the Billy's first name wrongly. So that may happen. So in that case, there is inconsistency in the first name. So there's a problem. So when this kind of situation happens, we are not sure which information is correct. Is the information in human resource department correct, or is the information in IT department correct? We are not sure about that. And also another example is this. So when he applied a job, he lived in this place. So one Bass Street. Actually, it's a she because I put female. Anyway, yeah. But it's possible later she moved to a new address. So she updated her address and she reported that to IT department where she works. So new updated address is stored in the IT department. However, IT department did not tell that to the human resource department. Then human resource department will have an old information. In this case, again, there is an inconsistency between two copies of the data. So that's another problem. So we want to reduce this problem by utilizing database approach. And the third problem was data isolation problem. So I'm not going to talk about this again here, but you can refer to the last week's slide. And also, there are several benefits we want to maximize by using database approach. One was data security, and another was data independence, and the last one was data integrity. So data integrity is something like this. So the data stored inside your system should follow a certain format, basically. So in this case, the data integrity is not really met in this example here because let's just say that in the human resource department, they store birth date information starting from day, month, and year like this. However, if you look at the IT department, they store birthday information from month and day and year. So there is uh, basically the way the data is stored is different between human resource department and IT department, even though they have the same data. So so in this case, we say that the data integrity is not met. Also for the salary information, so in the human resource department, they start with $sign and they put a number here like this. And in the IT department, they put number first and they use USD. In this case, also the format of the data is different, even though the value itself is the same. So in this case, again, we say that data integration is not met. So basically, by utilizing database approach, we want to maximize 3 benefits and we want to minimize 3 problems. So that's what we talked at the end of the last week. So let's talk about the database design. So today we are going to talk about database design, and the first step of database design is the modeling. So data modeling involves using a formalized methodology to create a database design. So basically, in the database system, we have 2 widely used methods for the data modeling. The first one is entity relationship modeling, and the second one is normalization. So in our course, we are going to talk about entity relationship modeling, and we are going to focus about this. So that's the main thing we are going to talk about today. And the normalization, today's course, we are not going to talk about it because it's kind of normalization is only used in a very specific situation. That's one of the reasons. So entity relationship modeling, we use it to build a new database design. So whenever you work in a company and the company wants to develop new database system, then the first thing you will do is entity relationship modeling to design database. And normalization is used to make a transition. So let's say that the company has been operating for a very long time. So previously, when company has a data, they stored all of their data inside the Excel file. So that's possible. In that, however, now there are a lot of database systems. So the company wants to move their data stored in Excel file into database system. Then they usually do the normalization. However, normalization is used a long time ago because back then, like a long time ago, when the database system is newly developed, many people wanted to transit their system into the database system. However, nowadays, every company has a database system, so we usually don't use this approach anymore. In some specific situation, they may use it, but yeah, so it's less important in my opinion. So we are not going to cover about that, but you can find more information online or through the books that I recommended in the first week. So entity relationship modeling itself is actually a top-down approach. So it's suitable to structurally construct database. So when you have nothing and when you want to build a new database system, then you have to do entity relationship modeling. So we are going to talk more about that later. And the normalization is actually bottom-up approach because it starts from the data. So normalization, it starts from data. So you already have data stored in Excel file, and you want to change the format of the data stored in Excel file, which will be better fit in the database system. So that's why we use normalization. Yeah, so yeah, Kai-Sin actually provided some information on the Zoom chat box. And yeah, it's the step of, yeah, basically that's the step of normalization. So yeah, that's wrong. Okay, but anyway, yeah, this is the kind of step of the normalization. So in the Excel file, as I showed you earlier in an example, there are a lot of redundant fields. Then they want to remove it and they merge it, right? So they resolve better dependency. Basically, they resolve problems and they translate it into the database system. So that's the kind of steps of normalization. So it's suitable to transform and feed Excel data into the database system. Okay, so that's there. And let's talk about steps of database design. So basically, in the database design, we'll go through these 3 steps. The first step is conceptual data modeling. Basically, this is what we are going to focus. Let me see. Yeah, the conceptual data modeling is something that we are going to focus on today. So as a result of conceptual data modeling, you will have something called ER diagram. So today, I'm going to show you a lot of examples of how to create ER diagram. So the best way to learn something new, if there's new concept, if there's new knowledge, if you want to acquire it really quickly, the best way is through the examples and practice. So I'm going to focus on that. So it's very similar to this. So let's just think about building, making a building. Then what you need to do is this. So first, you will think about some conceptual idea, right? Conceptual design. What kind of a building and what kind of things you want to put in the building. So maybe you will think that you want to have 3 bedroom and 1 toilet and living room or something like that. So you will have a basic idea, and later you will have a more detailed plan. Like what's the exact length here, and how big it should be the room or something like that. So you will make the detailed plan, like blueprint. So the making a conceptual design is similar to the conceptual data modeling in the database design. And making a more specific blueprint is similar to the relational data modeling in the database design. So this one, relational data modeling, we are going to talk with next week. So in the next week's class, we are going to talk about this. And the last step is this. Once you have a relational data model, then you simply implement. So when you have a blueprint, you just give a blueprint to the constructor. Then they will see the blueprint and they will follow exactly what's written on the blueprint. Then they will be able to build a building, right? It's the same in the database. Once you have a relational model, you simply follow it, then you will have you'll be able to physically implement your database system. So you will have your database implemented at the end. So here the thing is this. The most important thing is the conceptual data modeling, because if you have any mistake in the conceptual data modeling, let's say that if you have any mistake in the ER diagram, then that mistake will still exist in the relational model because you are making relational model based on ER diagram. And also, if you have a problem in the relational model, that problem will exist in the physical implementation because you are going to implement a database system based on relational data model. So what we talk about today, conceptual data modeling, is actually very important. And here's an example. So this is an example of conceptual data modeling. Basically, we are going to make a diagram like this today. So we are going to talk about how to make this kind of diagram from the company's business event. And then later, next week, we are going to talk about how to make a relational model and how to implement the database system in the MySQL. So that's today's plan, basically. So let's talk about it. Let's talk about entity relationship modeling. So entity relationship modeling by itself, it is the process to plan and create database. So after you do entity relationship modeling, what you will have as an output is blueprint for database design, basically. So after entity relationship modeling, you will have this blueprint called entity relationship model, basically. And you simply need to follow several steps to do entity relationship modeling. The first step is this. You have to identify a business event and its related business rules. So let's say that there is a firm, right? So if you are a database designer, you will work in a firm or in a company or in an organization or institute or something like that. So you will work somewhere, and the firm or organization, they will operate some kind of a business, right? So it may be business making profit, or if you work in an organization, it may be business process about a kind of a non-profit. Yeah, so that's also possible. Anyway, so firm has many business events, and based on those business events, you have to identify it. And for each business event, you have to identify what are the related business rules. So I give you more examples about this later. And based on your business event in a company and based on its related business rules, the next step is simply deriving the entity relationship diagram. And when you derive an entity relationship diagram, you should be able to identify these four main things. The first one is an entity. Basically, it's the table. So what kind of data you want to store. So something like whether you want to store customer data, whether you want to store product data, something like that. And attributes. So each entity, so last time we talked about this, right? So each table in the database system has columns and the rows. So row is record and the column is a field or attribute. So basically you have to define for each entity what kind of attributes, what kind of detailed information you want to store. So that's the second step. And the next step is defining relationship. So there are multiple entities and how these entities are connected to each other. So we have to define the relationship. And the last one is cardinality. So how one entity is associated with another. So that's cardinality. So we will talk more about that later. So basically, you have to be able to define these four things when you derive entity relationship diagram. So let's talk about one by one, starting from the business event. So this is a basic definition. So business event itself is a definable occurrence in a business scenario. So it can be a common high-level occurrence, such as a customer placing an order, or also it can be a more specialized event, such as a customer exceeding a credit limit while placing an order. So let's say that you are working at a retail company. Then in a retail company, there could be many different business scenarios that may happen. So one of the most important thing is a customer place on order, right? So if you are working in a retail company, the company's purpose is selling a good or selling something to a customer. So customer will come to your store and they will buy something. So customer place an order is one example here. And also other example can be something like this, like a small business event, right? When customer try to use a credit card, it didn't work because the customer exceeded a credit limit. Then that's another business event that may happen. Then what you have to do in that kind of situation, something like that, right? So example of business event is basically anything that can happen in a business scenario in your company or organization. So in the university, there's this example. So yeah, I'm teaching this course. So basically professor teaching a course in a university is another example of a business event. And again, customer placing an order in an online shopping mall, that's another business event. And customer's order being rejected by exceeding a credit limit is another example of a business event. So the next step is this. So once you identify what kind of business event exists in your company, then the next step is identifying and inferring the business rules. So what kind of rules exist in this each business event? So it's this. A business rule is defined as a statement that imposes constraints on a specific aspect of a business event from the perspective of how the organization perceives and uses its data. So business rules must be in writing and kept up to date. So basically, when you do like a conceptual data modeling, you should be able to identify business event. And for each business event, you have to identify business rule. And the company should keep those business rules in writing so that there's no confusion among the employees and among the people working in the company. So business rules should be always kept in writing and it should be up to date. So if there's any change in the company's policy, the business rule should be updated too. So in the database design, identifying correct business rules are very important because when you infer ER diagram, all these diagrams will be made and created based on what you write as a business rules. So that's very important. So basically, you can think about this. So again, there's a firm or organization or institution, and this firm will operate several, uh, will have several business events. So while they are operating some business, there might be several things may happen. So we call that as business events. And after you identify business events, for each business event, you have to infer appropriate business rules. So that will be basic steps. So let me give you an example of what are actually the business rules and how we are able to infer business rules. So let's just think about business event. Let's just think about that your firm is university. So in this situation, right? So let's just say that a university, there are many business events that may happen. And one of the business events in the university is teaching. So teaching in university. And let's say that we want to identify business rules about which is related to this business event. Then we may have this type of business rules. So something like this. So the university may have this rule, so professor may or may not teach in the current semester. So basically, professor is going to teach in the university. However, it's not necessary for every professor to teach in every semester. So that may be one rule. So professor may or may not teach in the current semester. So some professor will teach, some professor will not teach and focus on their research like that. And another rule that university may have is this. When the professor teach, he or she may teach more than one course. So it's not necessary for a professor to teach only one course. So when professor teach, it's possible they may teach more than one course. So that's also possible. So that's another rule the university may have. Another rule can be this, like co-teaching. So co-teaching is a course basically taught by more than one professor. Let's say that for simplicity, the university may impose this rule. So co-teaching is not allowed. In that case, each course should be taught by one and only one professor. So that's also possible business rule that may exist in the university. So these are examples of business rules basically. So basically, business rules are something, so some kind of a constraint or some kind of restrictions or some kind of ways of how this business event works. So you have to, in the form, basically you have to identify a business event that may exist in the form. And once you identify business event, you have to infer all these rules. So what kind of rules may exist and what kind of restriction, what kind of limitation, what kind of things that we have to impose in each business event. So you have to think about that and you have to keep it in writing. So that's the example of business rules. So the next step is this. Once you identify a business event and once you infer business rules, now we have to do the entity relationship modeling. So we actually start drawing something. So we are actually going to start to draw a diagram, which we'll call as entity relationship diagram. So first step is this entity. We have to identify what kind of entity exists and what kind of entity we want to create in our database. So entity itself is a component of data, and an entity can be any object in the system that we want to model and store information about. So examples are person, place, things, or event. So in this step, basically what you need to think is this. So let's say that we have this business event. Let's say that we have this business rules. And based on this, what kind of information we are interested in storing in our system? What kind of information we want to store in our database system, in our company, or in our organization? So that's what you need to think in this step. So let's think about earlier example. So you are usually able to derive an entity from the business rules. So earlier, we created 3 business rules here, as you see in this slide. So the business event was teaching in university, and we inferred these business rules. And here, if you just look at the business rules, you'll be able to infer what kind of information this database system should have to store. So the first one is this, right? The professor, basically. So professor is teaching. So we want to keep the information about professor. So we have to create that as an entity so that we have a place to store about the professor information. And the second thing is course, right? Because professor is teaching a course and we want to know what kind of course exactly they are teaching. So course is um, another entity, and we want to store detailed information about course in that entity. So basically, from this simple example, we are able to identify two entities we want to create for the database. One is professor, and the other is course. And in the ER diagram, in the entity relationship diagram, we have to make a diagram for this entity. And usually, we use this box shape. So in the ER diagram, we draw this box shape and we write down the name of entity inside. So there's a professor entity. And for the course entity, we do the same thing. We make a box and inside we put the name of the entity. So that's how we represent the entity inside our ER diagram. So that's it. So again, yeah, if you have any question while I'm talking, yeah, just use the Zoom chat box and the WeChat group. So if I'm too fast or if it's too easy, please let me know. Okay, so let's go to the next one. So the next one is attributes. So once you identify entity, you want to know what kind of attributes you want to create. So attribute itself is an item of information which is stored about an entity. So there's an entity, and each entity needs to keep the detailed information about each observation. So basically, entities will have attributes that describe the entity's characteristics. So let me show you an example. So earlier we created a professor entity, right? And professor, about each professor, we want to store many different information. Then each of this information, uh, we call that as attribute. So for professor, we want to store staff ID and name of the professor, and we also want to store office information, email information, and the phone number. So we want to keep this information in our database system. Then we call each of this as attribute. Same for the course. So we have a course entity, and for each course, we want to store course ID, course name, and also time of the course and the location of the course. Then we create 4 attributes like this. And in the ER diagram, each attribute is represented inside a circle. So for each attribute, we simply draw a circle like this, and inside we put attribute's name, and for each attribute, we link it to the corresponding entity. So we know that this time attribute belongs to course entity in this case. So that's it. And one more thing here is this, the primary key. So if you remember correctly, then last week we talked about this a little bit. So every entity should have a primary key. And primary key is an attribute that is able to uniquely identify one record from others. So same here. So when you are drawing ER diagram, for each entity, there will be multiple attributes, and you have to identify which attribute is a primary key. So in this case, yeah, basically every entity must have a primary key. So in this case, for the professor, they have a staff ID, right? So staff ID is a unique number assigned to each professor. So using the staff ID, we are able to identify one professor and distinguish one professor from others. So if you know that this attribute is a primary key, then what you need to do is that simply underline below the name of the below the name of attribute. So same for the course entity here. The course ID will become a primary key. So we simply put the underline below the course ID like this, so that when other people see this diagram, they will know that this course ID and the staff ID will be a primary key of this entity. So usually we use an ID field as a primary key, like a staff ID, course ID, Hong Kong ID, user ID, customer number, or something like that. So yeah, and we'll use an underline for primary key attribute in the ER diagram. So that's what I talked about it. Okay, so that's it. So basically, we talked about how to identify entity and attributes and how to draw them in the ER diagram. And the next one we need to identify is a relationship. So now we have a multiple entity in our database design in the ER diagram, and we want to infer and mark relationship in our diagram. Basically, relationships illustrate an association between entities. And there are multiple different types of relationship that may exist in our database design. So let me talk about that a little bit. So the degree of relationship, it may different. So one of the possible type of relationship is a unary relationship. It is possible for an entity to be associated within a single entity. So basically, something like this. So one entity is associated within itself. Then we call this as a unary relationship. And how to represent this in ER diagram is like this. So we had this entity with a box shape, and for the relationship, we simply draw the diamond shape like this. And we type the name of the relationship inside, and we simply link this relationship to entity like this. So in this case, it's a unary relationship because the entity is related within itself like this. So I'll give you more example about this later, but that's one type of relationship that may exist in the database design. And the second one is a binary relationship. So in this case, two entities are associated together to each other. So we draw this and we represent this in the ER diagram like this. So there's one entity, there's another entity, and we make a relationship in the middle, and they are related to each other. In this case, two different entities are associated together. Then we call this as binary relationship. And another type of relationship is this. So sometimes it's possible more than two entities are associated together. So here I said ternary relationship is the one with the three entities associated together. However, sometimes it's possible more than three are also associated together. So in this case, we have a ternary relationship. So there is three entities here, 1, 2, 3, like this. And all three are related together with a relationship in the middle like this. In this case, we call this as a ternary relationship because more than two entities are related together. Okay, so Ming asked one question here. So is a unary relationship would occur self-update of entity? Yeah, I'm not sure exactly what this question means actually. Can you can you put it in another way? Yeah, I'm not sure whether.
Can you hear me?
Yeah.
Yeah, so what I mean is that when you put the data into the relationship, is that will define a new entity into the database?
You mean whether relationship?
Like how's the data flow here?
I'm sorry. So how the data will be? Your question is how it will be represented in the database system when you create a unary relationship.
Yes.
So yeah, so currently, yes, currently what I'm talking is more of the conceptual design. So yeah, we are going to talk about how the data will be represented actually next week. Yeah, I give you more examples of the unary relationship. Yeah, so I think for now, yeah, just I think for now maybe it's better. Yeah, just understand that there are three different types of relationship like this. So today we are just talking about the conceptual thing. So basically, it's we are not talking about how database will keep the data and how it will be implemented. So we are going to talk about that in the next week. But let's consider what I'm talking today at a conceptual level right now. Yeah, I think in that way it will be easier to understand. And later, yeah, we'll talk more details about how this will be implemented in the database system. So yeah, so let's do that. Yeah, I think that might be better. So let me actually show you some example. So it will be better to understand this by using some example. So let's say that the government want to keep information about mother and child relationship. So we want to represent mother and child relationship in our database system. So something like this. So Sujan is mother of Tom, right? In that case, if we want to make a database system to keep this information, then the first step is conceptual data modeling. So at the conceptual level, we have to think how it will be modeled. So this is actually example of a Unary relationship. The relation is this: the Sujan and Tom, right? Basically mother and child. It's mother is a person, right? And the Tom is child is also a person. So basically, even though it's mother and child, we define it differently, but at an essential level, they are the same thing. So we will be able to derive person entity to represent mother and Tom. Basically, we are able to represent Sujan and Tom using the person entity. So we can create that. And person entity, so after defining entity, we have to define the attributes. So let's just say it's the Hong Kong's case, then every person will have a Hong Kong ID, which is the unique information for every person. So we put Hong Kong ID attribute as a primary key like this, and the government want to keep record of a name, maybe age, and the date of birth, and some other information like this. So we have multiple attributes in this case for the person entity. And the next step is representing the relationship. So it's a mother and child relationship. Basically, it's a unary relationship because mother-child is this. So it's a Sujan is mother of Tom. So basically, one person is mother of another person. So we create relationship called the mother of using the diamond diagram to represent a relationship. And it's the unary relationship because one person is mother of another person. So that's one example of a unary relationship. So basically, yeah, we are doing conceptual data modeling. So this relationship can be conceptually designed in this way. So let me give you another example in this case. Let's give you another example of a binary relationship in this case. So let's think about this case. Professor can apply for a parking permit in the university. So professor may have a car and he may want to apply parking permit in the university. Then here there are two information we want to store in our database system. So basically we need the professor information. So professor can be one entity and another entity can be permit, right? So we want to keep information about the parking permit in this case. And we can identify attribute. For the professor, they have a staff ID as primary key and the name, email, and office, and other information. For the permit entity, same. So we want to keep permit information in our database system. Then each permit will have a unique permit number. So permit number is primary key, and other information like location of the parking lot, right? Location of like outside the parking space, and something like a space maybe, or something like that. Yeah. So we can. So in this case, we are able to identify two entity and attributes like this, and basically the relationship will be like this. So professor apply or has, right? So professor apply for a parking permit like this. So basically this apply relationship is a relationship between two entity. In this case, we call this as a binary relationship. So this is one example of a binary relationship. Okay, so the next thing is this. So it's the last step. So after you identify all the entity and attributes and relationship between entities, so you did everything. And the last step you need to do is defining the cardinality. So cardinality is about identifying the minimum maximum number of times an instance of one entity can be associated with an instance in the related entity. So that's the basically definition. What it means is this. So basically we want to know how many times one entity can be associated with another entity. What's the minimum number of association that may happen, and what is the maximum number of association that may happen. So for the minimum number of association, we are deciding whether it's 0 or not. So we use 0 or 1. And maximum number of association, we are defining whether it can associate the max at 1 at max or more than 1. Then we call it many. So it's just something like this. So based on this maximum and minimum number of association that may happen, we may have 4 different cardinality type. So the first one is 1 mandatory. So minimum association is 1, maximum association is 1. Something like this. For example, let's say that, yeah, like based on the earlier example, I'll give this example again later, but like a mother, right? So if you think about child and mother, for each child, how many mother you can have? It's very simple, right? You will have a minimum 1 mother and maximum 1 mother, right? So you will have only 1 and 1 mother, basically. In that case, it's 1 mandatory. You must have at least 1. So in this case, I'm talking about biological mother, not the, yeah, sometimes people may have 2 mothers, 1 biological mother and 1 like a real mother or something like that. And the second type is 1 optional. You may have it or not. Something like driver license, right? Driver license can be one example. So if you don't get a driver license, you will not have anything. So minimum 0. If you have a driver license, maximum, you have only 1. So that's it. And also there's many mandatory. In this case, minimum 1, maximum many. This can be, what can be? Yeah, something, yeah, what can be a good example? Yeah, I'm not sure, but something like, yeah, I cannot think of like a good example, but something like a nationality, right? It can be one example. So you must have 1 nationality, that's for sure. And in the future, you may live in another country and you may get a green card or you may get a citizenship in a different country. That's also possible. In that case, you may have many nationality. Or citizenship might be the better word, I think. But anyway, something like that. And there is also many optional. In this case, minimum 0, maximum many. So this is something like a car, right? So if you don't buy any car, you may have a minimum 0. If you are like a car collector, then you may have more than 1, right? So you have many, maximum many cars. So basically, based on the cardinality, you will be able to, we are able to categorize relationship into 4 different types. So 4 different cardinality types: 1 mandatory, 1 optional, many mandatory, and many optional. So based on the maximum cardinality you have on each side of the relationship, we can call the relationship as 1-to-1 or 1-to-many or many-to-many. So let me give you some example here. Let's say that there are 2 entities connected using a binary relationship like this. So there's a relationship connecting these 2 entities. So this is a binary relationship because it's a relationship connecting 2 entities. And let's say that the cardinality is this. So from entity 1's perspective, the entity 2 is connected by 1 and 1. And entity 2's perspective, entity 1 is connected by 1 and 1. So in this case, the maximum cardinality here is 1. Also, maximum cardinality here is 1. Then we call this as a 1-to-1 relationship. So we define the relationship type based on maximum cardinality. So this information is useful. We'll talk about this later, but it's one way to identify the relationship. So in this case, here maximum cardinality is 1, and here maximum cardinality is many. Then we call this as one-to-many relationship. So I'll give you again more examples later, but these are some concepts that we may have. And in this case, both sides of a relationship, the maximum cardinality is many. In this case, we call this as many-to-many relationship. So based on the relationship, based on the degree of the relationship, and based on the type of the, based on the cardinality, we are able to determine the relationship type in like this. So let's talk about how to derive a relationship from business rules and how to define the cardinality from the business rules. So let's look at this example again. So this is the example that I showed earlier based on the business event, which is teaching in a university. So based on the business rule, we are able to infer 2 entity, professor and the course. And for 2 entity, we can identify multiple attributes which belong to each entity. And now let's say that we want to derive the relationship. So the first thing is this. It's the relationship about professor teaching a course in the university. So we can simply make a relationship called teach in this case and connect these two together. So it will be binary relationship between professor and course entity. And the next step is this. Now we want to define the cardinality. So we want to know how one entity is associated with another, and what is the minimum cardinality and what is the maximum cardinality. So we want to identify that. So to do that, we can simply look at the business rule. What kind of restrictions exist? The first one is this. Professor may or may not teach in the current semester. So professor may or may not teach. That means that professor may not teach. Then minimum 0 course, right? Because they may not teach. So that means 0. And may teach, yeah, it can be 1 or more, right? So we don't have that rule yet. If you read the next line, it actually talks about that rule. So when the professor teaches, he or she may teach more than 1 course. So basically, the maximum cardinality here should be many based on this. So we put the many sign here. So from the professor's perspective, they may teach 0 to many course. So that's what we can infer from this ER diagram. And the last one is this. The co-teaching is not allowed. So course taught by more than 1 professor is not allowed. So only 1 professor is able to teach a course. So from the course perspective, how many professors should be there? Minimum 1. If there's a course, there should be at least one professor who's teaching it, and maximum also 1. Because co-teaching is not allowed, only 1 professor is able to teach that course. So basically, it says 1 and only 1. So that's basically example of how you can derive the relationship and the cardinality from the business rules. So again, let me show you more example here. So earlier, we made this unary relationship, right? So we wanted to represent mother and child relationship. So what we did was this. So we made a person entity and attributes. I'll skip it. So we made a person entity and we made a mother of relationship last time, earlier, right? So we call this as a unary relationship. And let's say that now we have a business rule here. So business rule is this. China's one-child policy. So this policy doesn't exist anymore in China, but back then China had this one-child policy. So every family is allowed to have only 1 child, maximum 1, basically, right? So let's think about that. Let's keep that in mind and let's try to determine the cardinality. So let's think, so basically in this model of relationship, let's think from the mother's perspective first. So there's mother and how many child she can have. The minimum is 0, right? So even though there's one child policy, if I don't want to have any child, I don't need to have it. So minimum 0. And maximum, it will be only 1 because of this policy. You are allowed to have only one child. So for every person, so for every mother, basically, they will be able to have minimum 0, maximum 1 child. So 0 to 1. And for the child's perspective, it's still the same, right? There's a child. What's the minimum number of mother you can have? I mean, the biological mother. What's the minimum number of biological mother you can have? It's 1. And what's the maximum number of biological mother you may have? It's only 1. So basically, it's 1 and 1, right? So in this case, basically, the maximum cardinality is 1 here and also 1 here. So we call this as unary one-to-one relationship in this case. And basically, this is the final ER diagram you are able to infer based on this situation. So that's one example here. And let's think about the same one. But let's say that the policy is changed. So China's one-child policy is now ended. Then we can create the person entity again, and we can create the mother of relationship again. So in this case, let's think about the cardinality again from the mother's perspective here. So mother, now things are changed. But still, if I don't want to have any child, the minimum will be 0. I don't have any child. If I have a child, now I am able to have more than one child. So maximum many, right? So here it will be 0 and many. And from child's perspective, everything is still the same, right? Minimum mother I can have is 1. Maximum mother I can have is 1. Every child, they will be able to have only 1 and 1 mother. So here it is still the same, minimum 1, maximum 1. So in this case, if we only look at maximum cardinality of each side of this relationship, then maximum here is 1 and maximum here is many. So we call this relationship as a unary one-to-many relationship. So that's another type of relationship we may have here. Okay, so now let's just think about this. So instead of a mother-child relationship, we want to represent the parent-child relationship. So parent means both mother and father, right? So for this, let's just start the same thing. Basically, parent and child, they are all person. So we have a one person entity here, and instead of a mother of, we have a parent of relationship. So this relationship is still within person entity, right? So one person is parent of another person, like this. So now let's think about the cardinality here. So from the parent perspective, so I'm a father or mother, then how many child I may have? Minimum 0, still same. Maximum many. So it's the same, right? So it's 0 to many child each parent may have. And here, child's perspective. Now things are changed, right? So instead of mother, I'm trying to record the parent relationship. So parent, basically, they are mother and father. So there are two people, right? But in the database system, what we only care about minimum cardinal, sorry, what we care about minimum cardinality is only whether it will be 0 or not. So for minimum, you should have at least one parent, right? So actually 2, but at least 1. So minimum will be 1. Yeah, minimum will be 1. So let me draw it again. So minimum will be 1. And the maximum will, so maximum cardinality, you have to think about whether it will be 1 or more than 1. So for the maximum cardinality, you will have 2 parents, right? Mother and father. So 2 is more than 1. So we call this as many, like this. So basically, in this case also minimum one, maximum many. So in this relationship, if you look at the cardinality, it's many here and many here. So we call this relationship as a unary many-to-many relationship. So that's another type of relationship you can have based on this cardinality and based on this design. So those are three types of unary relationship you may have: unary one-to-one, unary one-to-many, unary many-to-many. And let me show you some examples of the binary relationship. Yeah, so it's the thing. So let me talk about this again. So the question is this: why the minimum is one, right? When everyone has two, right? So it's because of the database design. So in the relational database design, they cannot represent a minimum two or something like that. They are only be able to assess. So for the minimum cardinality, they are only able to assess two things. It should be either 0 or 1. So basically, if it's not 0, you have to put it as 1, something like that. So for minimum cardinality, 0 means 0 for sure, and 1 means actually not 0. So there should be at least one entity, one record should be there. And same for the maximum cardinality. Maximum cardinality is able to identify only one or many. So 1 is, 1 means just 1. So there should be at least, there can be only one record at max. And many is more than 1, basically. So if it's more than 1, we'll simply use many. So in this case, actually for a child, minimum 2 and maximum 2 is the correct way, right? But however, because of the database system, we are not able to put 2 and 2 here. So 2 means more than 0, right? It's not 0. So we use 1. And for the max, 2 is not 1, right? It's more than 1. So we use many. So that's why here we put 1 and many design like this. So yeah, I hope this makes sense. This clarifies your question. If you have any other question, you are free to ask on the Zoom chat box again. Okay, let's look at the next one. Yeah. So let's talk about binary. Let me show you some examples of binary relationship and different cardinality type. Earlier, I gave you this example, right? Professor apply for a parking permit in a university. So let's draw here again. So there's a professor entity. So let me skip the attributes again. And there's a permit entity. And professor will apply for parking permit like this. So that's what we made earlier, and we call this as a binary relationship. So now we have a business rule here. So we say that only one permit is allowed for each professor. So let's think about that. So professor apply for parking permit. So from the professor's perspective, how many permit they can have? So let's say that I'm a professor, but I don't really drive. So I don't apply for parking permit. That's possible. Then minimum, it will be 0. So I don't apply. And maximum, because of this business rule, only one permit is allowed. Maximum, it will be 1. I am able to have only one permit at max. And let's think from the permit perspective. So for each permit, if it's issued, it should belong to at least one professor, right? If there's a permit which doesn't belong to anyone, that doesn't make sense. Then why does the permit exist, right? So if there is a permit, it should belong to at least one professor, and yeah, maximum one professor. So each permit should belong to one and only one professor. So in this case, the maximum cardinality here is 1, and maximum cardinality here is 1. So we call this as binary one-to-one relationship. So that's one example. And let's look at another example here. So the same business event. So professor here applying for permit, the same business event. However, we have a different rule, right? Okay, so now professor, now there's a new business rule. So professor can apply for as many permits as they want. So let's say that again, here from professor's perspective, if I don't want to apply any permit, it's possible. So minimum will be still 0. But let's say that I have a multiple car and I want to apply for multiple permits for each car. Then it's possible now. So I will have a multiple permits. So it's minimum 0, maximum many. And from the permits perspective, it's still the same, right? If there's a permit issued, it should belong to at least one person. And maximum, it can be owned by only one person. So still minimum 1, maximum 1. So in this case, if you look at the maximum cardinality of this relationship, it's 1 and many. So we call this as binary one-to-many relationship in this case. Okay, so let's look at one more example here, the last one. So we have now new business rule. So we have 3 business rules in total. The last one is a permit can be shared by multiple professors. So the university wants to utilize a permit more efficiently, and they want to maximize the usage of the space. Then they may allow sharing the permit across multiple professors. So in this case, let's think about this. So we have the same business event. So we have the same professor entity here and same permit entity here and the same relationship, binary relationship in the middle like this. So here, from the professor's perspective, it will be the same. So he are still able to apply for as many permits as they want. So minimum 0, maximum many. So that's the same. So minimum 0, maximum many is still there. And from the permits perspective, now things are changed. So if there is a permit issued, it should belong to at least one professor. So there should be an owner, at least one owner of this permit. However, now permit can be shared by multiple professors. So one permit should be able to be owned by multiple professors. So maximum many. So in this case, we have a minimum 1, maximum many. So one professor may use this permit during the daytime, and another professor may use this permit during the nighttime, something like that. In this case, if you look at this relationship again, the maximum cardinality of each side, it will be many and many. So both sides are many. So we call this as a binary many-to-many relationship. So that's an example of 3 different types of binary relationship: binary one-to-one, binary one-to-many, and binary many-to-many, like this. So again, to infer and to derive relationship and the cardinality, you can simply follow the business rules. Then you should be able to draw ER diagram and create the ER diagram really easily. So earlier example again, if I just go really quickly, then we have this business rules, and between professor and course, when we have a binary relationship, we simply read the business rules and we are able to infer the cardinality. So it says may or may not teach. So minimum is 0, and may teach more than one course. So maximum is many. So same for here. Co-teaching is not allowed, so only 1 and 1, like this. So that's why identifying the correct business rules are very important, because when you design ER diagram, when you create the ER diagram, basically when you are doing the database design, everything, basically the ER diagram will depend on what you document as the business rule. So identifying correct business rules are important in terms of making correct database design. So let me show you one example of the ternary relationship this time. So far I showed the example of only unary and binary relationship, but earlier I told that there is another relationship, another degree of relationship, which is a ternary relationship. So sometimes it's possible for more than 2 entities to be associated together. Then we call this as a ternary relationship. So let's think about this. It's an example from earlier, the professor teaching a course. But let's say that we also want to want to make a semester as an entity. So in the university, there are multiple semesters, and the university also wants to keep the information about the semester in their database system. Then now we have a professor entity here, course entity here, and semester entity here. So for semester entity, we should be able to create three attributes, which is semester ID, year, and term number, or something like that. And there's a teacher relationship, which connect the professor, semester, and course. So in this case, how you define the cardinality is like this. So when you define the cardinality here about the course side, you have to think from other entities. So there is a professor teaching in a certain semester. So you have to think about this scenario. So a professor is teaching in a certain semester. How many courses he is able to teach? Minimum 0 if he doesn't teach in that semester, right? However, maximum more than 1, basically many. If he teach in that semester, he may teach many courses. That's also possible. And same for here. So here you have to think about it from the course and semester perspective. So there is a course offered in a certain semester. So there's a course offered in a certain semester. How many professors are able to teach that course? So co-teaching is not allowed, right? So 1 and 1. So there should be at least 1 and maximum 1 professor who should be able to teach this course in a certain semester. And here you have to think from the professor's perspective, teaching a certain course. So let's just say that there is a professor teaching a course. How many times he can teach this course? If he's not teaching this course, that's possible. In that case, it's 0, right? He may teach another course. And professor teaching a course, and he can teach across many different semesters. He may teach the same course over and over across different semesters. Then maximum many. So in the tonal relationship, basically it's the same. You are able to identify cardinality like this. So when you think about cardinality here, you think from other entities perspective. So that's how you define cardinality. And how you know what type of relationship this is, right? Whether it's one-to-one, one-to-many, or many-to-many. So in this case, you can also look at the maximum cardinality. So here max is 1, right? So it's 1. And here max is many, right? Many. And here maximum cardinality is also many. So when you have something like this, you only use 2 highest cardinality. So basically there are 2 many, right? Then we call this as a many-to-many relationship. So basically we consider this as the same as many-to-many relationship in the other cases. So in this case, we ignore 1 and we call this as a tonally many-to-many relationship. So basically if you have a 1, 1, 1, then it's a tonally 1-to-1. If you have a 1, 1, many, it's a tonally 1-to-many. So if there are more than 2 many and more than 1 many, then we'll call this as a tonally many-to-many relationship. But that's a kind of minor thing. So okay, so that's how you can derive the cardinality in case of the tonally relationship. So this so basically, yeah, that's all. So basically that's the basic steps. So I covered everything about how you can infer entity relationship diagram from the business event and the business rules. So you look at business rules carefully, and then you'll be able to identify all this entity relationship and the cardinality. So it's actually quite straightforward.